Good morning, everybody. You're very welcome to the fourth webinar celebrated in our project, BovINE. I am Virginia Resconi, Assistant Professor in the University of Zaragoza, Spain, and leader of one of the four thematic areas from BovINE, production efficiency and meat quality. So our guest experts, Alfonso Abecia from the University of Zaragoza and Russ Carrington, member of the EIP Agri-Focus Group from UK, will be the panelists from this webinar. So they're going to share knowledge and experiences on virtual fences to manage beef cattle. This is one proposed solution to address a priority need from farmers. The need is animal monitoring tools to reduce labor use and time-consuming work. So you can have a look in our website, further solutions to this and other topics we are addressing in BovINE. Mimi or Mary Saville at the end of this presentation will explain how to do it. So coming back to our topic of today, the idea of virtual fence is to control the animal movement from the mobile or the tablet without the need of physical barriers or a shepherd. So is this something that the farmer can only dream, or is an innovation ready to use in Europe? How does it work? What are the benefits and the challenges of this technology? So our guest experts will try to respond those questions. And also we would like to listen or read your own questions, opinions, or suggestions in the chat box at the end of their presentations. So we will start with Alfonso. His presentation will take around 30 minutes, and he will talk about generalities about virtual fence, and then he will share his experience on a pilot project in mountain areas from Spain. Alfonso is a full professor from the University of Zaragoza. He was also involved in electronic identification in small ruminants. He's the president of UECA, which represents the Spanish scientists involved in animal science in the European Federation of Animal Science. And he also works in the relationship between nutrition and reproduction, the use of melatonin and sexual signs in sheep. So you can start, Alfonso. Well, you can see him, but if you don't know him, I can tell you that he's very tall. So thank you, Alfonso, to participate today and for all your contributions and support to this project. You can start.
Thank you, Virginia. Can you see my presentation? Okay, yeah?
Yes.
So, sorry for this typical question, but we are never sure. Okay, thank you very much for to the BovINE project, and especially Virginia for inviting me to be here with you. I'm working in virtual fencing since maybe 6 years ago. My experience is because I'm part of a local project, a project supported by the local government of Aragon, and we are working with several livestock associations, and we are working with horses, with cattle, and with sheep. What I'm going to show you today is an explanation of what a virtual fencing system is, and at the end I will just talk about our project. Unfortunately, I can't show you a lot of information about our results because now they are confidential, because we decided at the beginning of the project to have our own system. We are not buying a commercial product that you can find in the market, and we are developing our own system of virtual fencing. Okay, so sorry. Let's have a look at the Oxford Dictionary of English. A fence is something like a structure that divides two areas of land, similar to a wall, but made of wood or wire and supported with posts. What is a fence for livestock? We can say that it's a structure or a natural barrier which is sufficient to confine an animal. What about the word virtual? Well, virtual means almost, but not exactly or in every way. So we can say that a virtual fence is almost a fence, no? But if we follow the definition of the CSIRO in Australia, they say that a virtual fence is an animal-friendly fencing system that enables livestock to be confined or moved without using fixed fences. So this is just a picture of a traditional fence for cattle. Here you can see electric fences that they are very used, very extensive, used in Europe for managing livestock. And this is a virtual fence. Of course, we can't see a fence at all because there are no fences in the system. What we can see is the animal with something in the collar, in the neck, and we can see that the farmer will have a laptop or a mobile phone to manage the animals. I would like to show you some advantages and inconveniences of, let's say, conventional fences, electric fences, and virtual fences. The first one, maybe the only advantage of a conventional fence is they are 100% safe for livestock, but however, they are not flexible, so they are fixed in the territory. They cannot be moved. They have, of course, a cost of maintenance that sometimes it could be expensive. Conventional fences produce injuries in the wildlife and can cause injuries to the cattle. An electric fence is the best thing is there's a very flexibility, can be easily moved, and it has less risks for wild or for domestic fauna. However, they also require maintenance. A constant ground connection is required and must be checked regularly. And sometimes we can have some animal welfare problems because we can have accidental electrification with the animals. And the virtual fence, it has a total flexibility, so it can be moved in seconds. It allows to, let's say, to fence places that are difficult to access and allows to regroup animals remotely. However, the inconveniences, something like that. There is no 100% of security that an animal leaves the fence. By not being visible, it can cause situations between humans and animals that may be unhealthy. It should be signposted in some way. Well, this is something that we can discuss. At this moment, there are not a legislation about virtual fences, but maybe in the future, if a herd of cows is managed by a virtual fence, maybe we will have to put a signal or something like that in the mountains or wherever. And the virtual fence does not retain wildlife. So this is a picture of a virtual fence for an e-shepherd, which is a system, a commercial system for virtual fencing. So a virtual fence allows to map livestock grazing to control the movement and location of animals within an area. It has no use fixed fences. And this is maybe the most important part of the virtual fencing system, that it is based in the global positioning system, or GPS. So it needs sensor and wireless technologies. This is another picture for Wageningen University, and we are going to see some parts of the virtual fencing system. So the animals need to be fitted with a GPS collar. This collar emits a tone and an electric shock, as we will see later. The farmer sets up a virtual fence using the tablet or the telephone. And as the animal approaches the predetermined virtual barrier, the GPS collar will emit first an audio cue. And if the animal continues towards the barrier, the animal will receive an aversive electric shock. So this requires animals to respond appropriately to the audio cue to avoid receiving an electrical shock. So the idea is that the animals are trained to the audio cue before using the electric shock. So the question, maybe the main question about virtual fencing is, are there animal welfare implications? So I would like to say that the audio cue is around 785 Hertz. The electric shock in a virtual fence is around 800 volts, delivered in less than 1 second. And on the other hand, electric fencing uses no less than 2,000 volts in the summer and around 4,000 volts in the winter. This difference between summer and winter is due to the thicker hair coats of the livestock. So an electric fence is using 5 times the electricity or the electric shock than a virtual fence. So this is only another explanation. When we are using a virtual fencing system, we have the grazing area, because the main aim, the main objective of virtual fence is to manage the grazing of the animals. We have what we can call the exclusion area, which is the area that we don't want the animals to be grazing in. And we have this border where if the animal crosses this border, the animal will receive the audio cue or the electric shock. As you can see here, this is a picture from a company called No Fence from Norway. So you see this is the border between the grazing area and the exclusion area, and you see this is something called the warning zone or the warning area, where the animal is receiving the audio cue, and if the animal crosses the warning zone, will receive the electric shock. Mimi, can you please play the video? This is a video from Non-Fence, the No-Fence company. I would like to show you because it's interesting. So you can see the animal is grazing. So you see the audio cue is working because it is in the warning zone, and the animal has received the electric shock and is going backwards to avoid the electric shock. This is enough, yeah. Thank you. So, sorry, I don't want to show the, 1 second, please. Okay, so I'm going to show you the components of the virtual fencing system. On the animal, as I said, we need a neck collar with an integrated negative electric stimuli capability and with a GPS system. In the cloud, we need a management system that links the animal to the manager, to the farmer. And in the hand of the manager, of the farmer, we have the capability to manage the virtual fence line. So we can draw the fence line, and we can observe the locations of the animals if we want, when we are at home or when we are at the farm, because this system also allows us to know the actual position of the animals in the grazing area. This is just an example of one collar. This is from Agersen, another company. You can see the GPS here. You can see here some solar panels, because of course we need some energy, and in some companies are using this solar energy harvesting system. Here you can see the aversive, the point where the animal receives the electric shock. Here, this is the audio cue, the place where the audio cue is coming, etc., etc. And this is, sorry for the Spanish here, this is the software we are using in our project. I just want to show you, this is an application for an iPhone, or well, it's for Android or for iPhone. So the farmer is based in Google Maps, and with your finger you can just draw the lines, and you can determine the grazing area. So I would like to talk about some key points of virtual fencing. First of all, it is very clear that the electrical stimuli is a negative signal. Most of the devices found today in the market are using acoustic and especially electrical signals to, let's say, convince the animal not to cross certain coordinates. This electrical shock is being discussed in the European Commission due to these implications on the welfare of animals, especially considering possible device failures. So these problems could cause a continuous electric shock in the animal. It is very rare and very strange, but of course it could happen. There are some alternatives to electrical signals. The most important alternative is the sound, although the sound seems not to work properly without the accompanying electric shock. So at the end, we need the electrical shock, but if we can avoid it with the sound, or maybe also a vibration in some solutions in the market, they have first a vibration of the collar, then the audio cue, and at the end the electrical shock. There are some applications of ultrasound, a very high sound in a very high frequency. Even they are called, because of this frequency, mosquitoes. So it is very bad for the animal, but it seems that at the end, as I said, we need the electrical shock. So we can use the electrical fence for moving animals by moving the fence. So in some examples, we can see how the farmer can move the herd to the farm, for example, just moving the lines, the coordinates of the virtual fence from your laptop, from your tablet. So you can something like push the animals to where we want. Another key point is the need of the learning by the livestock. This is very important when we are working at the beginning with these systems. We need the animals to be trained. So we need a prior learning of the animals regarding the type of signals they receive, and their subsequent reaction is absolutely necessary. This is very important. This learning can be done manually. So at the beginning, you can use a collar, something like the collars for dogs. And maybe you know this system to train dogs for hunting. So you can use at the beginning these collars, and you can send the acoustic of the electrical signal manually. So maybe at the beginning it can be useful to teach the animals to the system. And another key point is the energy. Maybe I think that this is the limiting factor for all the commercial solutions that we can find in the market, because the GPS devices consume a great deal of power. In theory, we need the system be in a continuous operation to prevent the animals from crossing the limits of the fence. But this is spending a lot of energy. As I said, some solutions are using solar squares to recharge the batteries, but another solution is to put the system in a standby phase if the animal is not moving, so we can save energy, and the system start again working when the animal starts moving. In any case, as I said before, the energy required for the system to work is the main stumbling block at this time. So these are some of the solutions. NoFence is a Norwegian company which is working a lot now in Europe, and we can find another two commercial solutions in New Zealand or in Australia. And this is our project. We call Barana Tech. Barana is the local name for a fence in the Pyrenees, in the mountains of Spain, in the border with France. And in this project, as I said to you, we are working with some associations of farmers, and we are working with horses, with cattle, and with sheep at the same time, and especially in the very difficult areas of the mountains. So this is very important for our farmers. They need a solution where they can't go with the electric fence every day or every week. So for them, this could be a very nice solution. So we are working in how to insert the system in the neck of the animals. We are working in this in the parts, in how to introduce in this small box all the parts of the system, and we are working also in the application. Of course, in our group we have engineers and we have people able to work with all these technologies. This is some pictures of our system, of our software. This, you can use it in your personal computer or in your mobile phone. It doesn't matter. And we are also working in the hardware because this is maybe this is the reason, especially the energy. We are developing some an energy system to avoid solar. So we are not using solar panels, although you see this picture here, and we are also trying to use what I said before, a system that it is in a standby position when the animal is lying or is not moving to save energy. And as I said to you, if you want to ask me questions later, maybe I can give you some answers. But at this moment, I can say that our system is working nice in the 3 species. Maybe the cows, the cattle is the most difficult species for us in terms of the electrical shock, the intensity of the signal. It is working very, very well in horses and in sheep. And this is what I wanted to talk to you. Thank you very much.
Okay, thank you, Alfonso, for your great presentation. So now we're going to give the word to Russ Carrington. He's member of the EIP Agri-Focus Group on Sustainable Group, who is training nowadays no-fence collars on cattle in the UK. He heads up the new regenerative farm at the NIP estate with a rewilding project running alongside. In the past, he was the general manager of the pasture-fed livestock association. So Russ, for sure, will explain well his project and his experiences with virtual fences. So I'm sure you will enjoy his presentation. So you can start, Russ.
Thank you very much, Virginia. Hello, everyone. It's really great to be here. So I'm going to talk about my experience actually using the no fence collar. And I thought it might be useful to see one, so I've actually got one here to show you, and fits around the animal's neck with a chain. It has this sort of green band to connect over the animal's head, and the whole thing weighs about 1.3 kilos. And then most of the weight is the battery, which looks like this, which you can charge up, and then it literally just slots in the bottom and clips into the collar, and the solar panels on the side of it to keep the battery charged. So I'm just going to give a bit of background to the project that I'm managing, and then explain why it's useful for us to be having these collars in use. So hopefully you can all see my slide now. So the NEP estate is in the south of England, just south of London, and it's been developing a really interesting rewilding project to explore how to make a switch from food production to producing biodiversity. And the way it's done that is to let the land rewild and let nature reclaim it. And it's portrayed a great deal in this book called Wilding, and I recommend reading that if anybody wants to find out more or looking up online. And this is the main focus of the estate. But I've just come on board at the beginning of this year to set up a new project which sits outside of the rewilding areas. And the rewilding areas I'm showing here on the map in blue, and then there's these other fields shown in green, which are forming the new regenerative farm on the estate. And this is where we're going to really experiment with some different techniques of grazing animals. The big focus of the project is to really understand how nature recovery can happen on a landscape scale, with having farmers, neighbouring farmers, collaborating and working together to help nature to infiltrate the landscape and extend beyond areas of refuge for wildlife and areas of rewilding, and actually take that on into the bigger landscape. Plus, we're trying to produce some really good food for local people and visitors to the estate. So we're producing some beef animals. We're starting a chicken enterprise for chicken meat and eggs. We're developing a horticulture project, and eventually we'll be establishing a small micro dairy as well for producing milk, cheese, butter, and so forth on the estate. The other thing we're doing is really trying to assess how we are changing nature on the farm. We're measuring lots of different things to understand how we're impacting and influencing carbon levels in the soil, wildlife levels, things like dung beetles, and also measuring as well the social impacts. What are we doing for people's health, access to green spaces, creating jobs, and contributing to the local economy. So we're doing a lot of measurements to understand those things. The soil is a key part of the project, and understanding where carbon levels are at, and we've had specialist equipment going out to measure some of those things. And things like dung beetles, we're doing different surveys and trying to establish new protocols for understanding dung beetle levels and populations on UK farms, because these things are actually really important for the health of our soils. But just taking a sort of overall picture and where it becomes relevant for the no fence collars is actually how do we create connections for nature across the landscape. And so thinking about the area of farming that I'm looking after, which is around 150 hectares, how do we create those corridors which connect up to the rewilding, where we know there are strong populations of biodiversity and different wild species? And so how can we use our things like our watercourses to create corridors by managing those watercourses differently, and then help things travel along and through the watercourses on through the landscape and to our neighbours' farms as well? And then also, can we use our hedgerows and our woodlands to connect on through the farm as well, and provide really important corridors for different species that are of benefit to our farms, such as swallows and bats, that can help us keep fly populations under control that otherwise might be a nuisance to our animals, and various other things that will predate and help keep the farm healthy. And at the moment, a lot of the hedgerows have been grazed by animals. The animals have been going into those hedgerows. They've been nibbling and eating what they can and destroying much of the sort of understory of those hedgerows, which makes them quite poor as habitats for nature. But they exist as old boundaries. I know this isn't necessarily a system that's existing right across Europe. Hedgerows are quite unique to many parts of the UK, but they're nonetheless very important habitats. And so what we want to do is to make these much better habitats and much better corridors, which to look something a little bit like the diagram at the bottom, where there was a gradual gradient of structure and vegetation that reaches right out into the field by several meters, and then creates this really good tunnel and corridor for nature to follow. So the big question is how we then do that, and how we still have a livestock enterprise without enabling these corridors to be created. So we needed a really dynamic solution to that, and that's what brought us to the no fence collars. And in doing so, we thought about the physical costs of creating a permanent fence with steel and timber to create a permanent boundary. And as Alfonso covered very well, there's some real limitations to that. And actually, the no fence collar or any virtual fencing really opens up a much more dynamic offering, a much more dynamic way in which we can manage the edges of our fields and boundaries and pastures and our hedgerows. So I've just been trialing this literally in the last 2 weeks. So we took a delivery of collars only 3 weeks ago, and I installed them onto these 4 cows, and I've been putting them into a trial paddock. And I'm just going to explain really my experience so far in just in 2 weeks, how it's going and how the collars are working. And the first thing to do was to set up the pasture. So for the trial, I chose a pasture that already had a fence around it, which we can see. Hopefully you can see my cursor. There's a hedge and a fence around this boundary, and then I set the virtual fence boundary well outside of that hedgerow, and it's recommended to be about 30 meters if you don't want any interference to exist. And then after a few days, I introduced this exclusion zone, which I'll say a little bit more about. So this was the first day of the collars, and so the animals were moving around most of the pasture. They were moving to the extent of the physical boundaries and the physical structures, hedgerows and fences that they could see. And the great thing about the No Fence app is it does provide you with a great deal of data on where the animals are spending their time. So that was sort of day one. I took the time to observe how the animals were behaving once they were wearing the collars. They weren't too difficult to put on. It was very helpful to do it with 2 people. It was well worth watching all sort of video tutorials that No Fence provide, and sort of following the instructions quite carefully. And so I'd certainly recommend that for anyone that was doing it in setting up the app, and the data that then comes from that is very useful to have. I also sort of took the view to try and match the boundaries to something physical. So in my mind, the animals would want to relate the audio warnings and the electrical pulses they might receive to something they could also see. And perhaps that's as a human trying to impose my ideas, but I felt that was a sensible place to start. The app and technology also helps guide the animals through, so it has a kind of teaching mode to ensure the animals are learning and getting the hang of what's going on. So I introduced the exclusion zone, which is this rectangular area. Again, I did it in conjunction with the physical fence, so they might associate it with something. And on that first day, several of them had audio warnings and electrical pulses, and they figured out there was something there. And then, as you can see, they were right at the other side of the field for most of that rest of the day. They kept their distance from this strange area that was making sounds every time they went near it. But the day after that, they really became more comfortable, and they started exploring further up to that boundary, and they started to learn where it was. And it was very, very interesting to see how quickly those animals did begin to learn how they were working. And so there was really good data provided by the app around how many times each animal is getting an audio warning and how many times it's getting an electrical pulse, which you can hopefully see here a little bit as well. And it's definitely sure that some animals are experiencing more electrical shocks, pulses, and audio warnings than others are. And it's providing an interesting insight into the whole dynamics of the herd structure and the animals which are the followers and those that are the leaders. So that's all I wanted to say, but I just wanted to show a quick video, which hopefully Mimi can bring up for us, which sort of shows these in action that I filmed last week. Of the animal at the front is the pioneering animal grazing up to that exclusion zone that I found. So she hears the sound, there lifts her head, realizes something's going on. But what was really interesting here is the whole herd then turned around. So it wasn't just the animal that it was at the front edge, the whole herd were then turned. And this comes a little bit back to how cattle work, how the whole herd dynamic tends to work. But it's really made me think about how we create those nature corridors and hedgerows and edges in the way that we want to do. And so what this isn't delivering is a really straight edge where some areas are grazed and some areas are not, in the way that you would get with a permanent fence or an electric fence. The edge is actually much more dynamic. and that perhaps spans over 5 to 10 meters where you're getting that difference from one thing to another. Now for nature, that's really great. That's providing diversity, and that's not an issue for really big grazing areas where conservation is going on over thousands of hectares. But we're trying to make it work on a small area and grazing small paddocks and moving those paddocks every day. So it's providing some interesting thoughts for us around how we do that, how we create those edges that we're looking to do for nature using these colours. But we've got a long way to go, so we're really interested to keep learning and keep sharing with other colleagues around Europe how they're getting on with those. So that's very quickly all I wanted to do and share and say for now. Thank you.
Okay, thank you, Russ, for your presentation. So now it's time for questions or suggestions. If someone else had experiences, could be nice to hear as well.
There are a few questions in the chat box already. The first one after Alfonso's presentation was, are there any cost analysis yet? How much is the cost, do we think, per animal per farm? So maybe we could take that one first.
Alfonso, your microphone is switched off.
Okay, no.
Yes.
Okay, it was controlled by. Yeah, well, maybe Russ can answer this question better than me, because as you know, Virginia, we were discussing the other day this economical aspect. I don't know. I can give you an answer because we are not at this moment calculating costs, and we are not using commercial solutions. Maybe Russ can give it not only the price of the collars, but maybe your opinion about the how to optimize the price and the use of these things, avoiding normal fences and things like that. I'm sorry, but I can't give you. I don't know who asked the question, but I can give you now an answer for regarding economical aspects of this system.
Yeah, it's a very good question, and I think it was one topic that I was nervous about. Did it really make sense financially? And I think in truth, it doesn't at the moment. But the technology is getting cheaper, and I think the way that these sorts of collars have advanced over even relatively few years shows how quickly things could change. So I've bought 10 collars to try to learn with, and I'm seeing they have other benefits besides just saving time, because they're enabling us to do things we were not able to do before. So that perhaps has a different value. And as in the UK at the moment, we are moving to an agricultural system that's is less focused on food and more focused on biodiversity. Maybe there's more value in these collars for that. But across our farm to fence, permanently fence all of the field boundaries was going to cost around £80,000. Whereas not spending that money and spending it instead on the collars, that buys us a lot of collars for a lot of animals, and I think does enable us to do something much more interesting for the future. So that's kind of where I'm at and my thoughts on the economics so far.
What
Yes.
Virginia, can I give another point? What it is very interesting is what Russ said. The possibility of not you don't need to put a collar in the whole head. Maybe you have some leader animals or animals who are able to show their response to the virtual fence, and it's likely that the rest of the animals will respond following the reaction of these animals. So I'm not sure the percentage of animals you need to have with the collar, but what I definitely think is that you don't need to put collars in the whole herd. What do you think, Russ? No, it's that the rest of the animals. The problem is if one of your leaders is not wearing a collar, no, of course, but maybe you need to detect the leaders of the herd, of the flock, and then put the collars in these kind of animals. No?
Yeah, I think that's an idea, and I've not heard of anybody yet that's really made a success of doing that. I think it requires very good stockmanship to identify which the leaders are, and it's not always the same ones one time to another. And I think in my experience with the video just shown there, the other animals at least associated the sound and behavior of the front animal with the fact they had experienced the sound themselves on an electrical pulse. So if some of the animals didn't do that, then I'm not sure how that would happen. But I think if you have enough collars in the herd so that you have the majority of the herd and leaders, then that should work, and they should all then follow. And animals do learn very, very well. Cattle do, for sure.
I know some groups in Europe, they are trying to connect animals by Bluetooth, for example. So you have some animals with the GPS collars, and the rest of the animals don't have a GPS, which is the most expensive part of the collars. So you can connect by Bluetooth all the animals. So if the animal with the GPS has the audio cue or the electric shock, can transmit this thing to the rest of the animals, and it could be cheaper than all the GPS collars, but it is only an experimental thing so far.
Another question links to that. Somebody has asked, is it necessary for some period of adaptation of the animals? I mean, Russ has said that it's very early days for his, but he showed in that data collection that there was change in a relatively short period of time. What about you, Alfonso, in terms of the work you've done?
Yeah, it's the same. We wondered when we were trying the first collars, in a few days, in a few hours, they learn very easily, and especially the audio cue. Horses, for example, the horses we were using, they respond very well to the beep of the collar, and just when they were listening to the audio cue, they turn back, turn around. So, but definitely you need a learning process that it could be shorter or longer, depending on maybe the species and how you manage, and of course also the kind of landscape you have, and if you have trees or you have real fences around, because maybe the animals are able to associate a particular area, a particular landscape, trees or grass or things like that, to the virtual fence. And if you move them to another place, a very different place, maybe they again need to be trained to a new situation, no? Something like that, no, Russ? So, yeah.
I agree, and it's kind of not a replacement for stockmanship. It was very interesting. We had some very hot weather here last week, and the animals were seeking shade, and I was being very conscious that I need to be stood in the field in the midday sun to see where the shade was, to understand where I needed to make sure the animals could access. And then I also started noticing that they were spending a lot of the night time in one particular corner, or they were spending that time as a cudding area when they're chewing the cud. And so I think we don't understand as humans quite what's going on. They're liking certain areas for reasons we don't understand, whether something's going on underground with the water table or what. But it's important to still, I think, give those animals access to a range of different features: tree, shade, cool areas, sheltered areas, safe areas for whatever reason, and not to try and block them out. I think that's important for animal welfare. We're pasture fed certified on this farm, so that requires very high standards of animal welfare.
And related to that, another question really about welfare is the collar uncomfortable for the animal? Is there any evidence of distress or issues related to the wearing of a collar that's been noted so far?
Well, of course, at the beginning, this is something strange for the animal, and they don't like it. But I don't know in Britain, but in Spain is quite and it's not unusual for cattle, especially for cows, to wear how you call in English a bell, no, to like in the mountains. So I think maybe it's heavier than the normal bell that the cows have in the mountains in Europe. But I think that's not an issue, no. Not, well, if it is not very heavy, of course, no.
I've been keeping a close eye on that, and particularly where it goes around the back of the neck of the animal. I was checking to see if there was any kind of rubbing or soreness coming, and absolutely nothing at all. It's not so tight that it doesn't move, and the rubber strap is very soft and comfortable. So it seems not to be an issue. And I think after 12 hours of wearing them, they were used to it. It was funny to watch them at the first because they were sort of spinning their heads around, wondering what was around their necks, but they soon seemed to get used to it.
And another question about grazing. With your virtual fence, do you find that perhaps there's overgrazing further away from the virtual fence than you would like? i.e., because of them being wary of being near the virtual fence, they tend to graze and perhaps overgraze in other sections in the area in which they're being allowed to graze.
Yeah, but well, that's not the idea, but it is what you want. You want to the animals being grazing in a particular area, and then you, in a few days or after several days, you change the grazing area. So this is very nice for rotational grazing. So the idea is moving the animals or changing the paddock after, I don't know, 1 week, 2 weeks, depending on your animal density. So, but it is a very nice solution for rotational grazing.
Mm-hmm.
I'm finding that the animals are still testing the boundary every day, but after the first week, there's very few are now getting an electrical pulse, so they're all responding to the audio, and they're getting maybe 1 or 2 audio reminders per day. So yeah, they're learning, but they're just every day they're still testing where the edges are.
That's all the questions and comments that are in the question and chat box at the moment. So, thank you.
Okay, so thank you, our experts, for explaining this technology. Well, also I would like to say that we are working in the questions that we had about. We will try to put price or economical aspects to these virtual fences. We will try to form a group with people in Europe working on that, and maybe we can arrive to some conclusion. Let's see. So that's it. So thank you everybody to be here, and thank you our panelists. And I will give now the word to Mimi. Okay, thank you.
Perfect. Thank you very much, Virginia. And as Virginia just said there, thank you very much to Alfonso and to Russ as well. Just before we close off, I'd just like to invite you all now, please, to connect with the BovINE project. We have a variety of online channels where you can connect with us. These are our website, as well as our social media. And from our website, you will be able to register for the mailing list, where we will send out infrequent information via email, alerting you to project events and activities. We also invite you to join and register the BovINE Knowledge Hub, and this is our online repository of good practices and research innovations that are really tailored to help good practices on the farm for cattle and for farmers. You can also watch our previous webinars, which are available on YouTube via our YouTube channel. And of course, please do get in touch with us via the contact page on our website, and also via the network managers page if you're looking to contact the network managers for information about joining the local networks. The Knowledge Hub is also a really great place to grab information, and it's very quick and easy to join, so we do invite you to join us there. So thank you very much, everybody, and have a wonderful evening, and we hope to connect with you soon again through the project.